This is Group 2B with
Maya Howard.
Jenna Snyder.
and Cameron Bennett.
Experimental goals and main ideas. Our research question is, how can we find the charge of a balloon? Our experimental goal is, by using tracker video analysis, we can find the acceleration of two charged balloons repelling and then use the force equation to solve for the charge. Experimental design. Our materials included two balloons attached to a singular string, a meter stick, tape, a scale, human hair, a smartphone for visual recording, and tracker analysis. Design. Two balloons were attached to a string that was taped to a flat plastic surface for data collection purposes. To charge the balloons, each balloon was rubbed on human hair for approximately 10 seconds. After charged, both balloons were held near each other and were then released to observe the repulsive interaction. Through video recordings, tracker analysis was used to analyze the acceleration in the x direction by using the meter stick to account for the displacement of the balloons. This experimental design underwent 3 separate trials.
We assumed for this that both balloons will have a repulsive interaction with each other, in that both balloons were charged on the same human hair at the same time and for the same duration of time, and that the balloons will primarily move in the x direction, however, movement in the y direction and z direction will occur.
For our models, we made a system schema and force diagrams. For the system schema, we found that there was an electric force acting between the two balloons and the tension force with the string on the two balloons. We found that the follows, and they were used to analyze the data that was found in Tracker.
For trial 1, we recorded the individual motion of both of the balloons at their edge from the time that they are first interacting to like their motion of like repelling and kind of falling back toward each other for a couple of seconds. As you can see in this trial, they have relatively like opposite peaks because they were plotted on the same plane. So the furthest acceleration of the pink balloon was like relatively opposite to the negative furthest acceleration of the Y balloon or the yellow balloon. For the analysis, we did all this lovely math. And as you can see, our electron total for our balloons are 4.25 e to the 12 electrons for trial 1. For trial 2, we did relatively the same thing. As you can see, the peaks are in like opposite of each other, and we did similar math, and we got a total of 1.8 e to the 12 electrons for this trial. And then for trial 3, you can see our data from here. And then for trial 3, we have an electron total of 9.41 e to the 11 electrons, based off of the previous math that we showed.
Areas of uncertainty. So there was 2 areas of uncertainty. We had systematic errors and random errors. Our systematic errors included apparatus structure, such as tension on the string, x, y, and z coordinates, as well as limitation of tracker analysis. Our random errors included unintended electrostatic interaction with surroundings that were not in the system in question, such as the plastic background that we used. We repeated this trial a few times rather than many times, so that led to an increase in uncertainty and margin of error.
In conclusion, we were able to calculate the charge of the balloons from the distance apart at the point that the net force was 0. The yellow balloon was typically found to have a slightly higher charge than the pink balloon. The amount of electrons transferred to the balloons varied greatly between the trials.